the square root of 4 secant squared theta minus 4. So we plug our thing in for x. How does that help? Take out the 4, all right? So that's the square root of 4 times secant squared theta minus 1. I can take out a 2. The square root of 4 is 2. And how about secant squared theta minus 1? It's the same thing as tangent squared. How come? It's one of the Pythagorean identities. So if you look at this one here, if I move this 1 to the other side, secant squared minus 1 is the same as tangent squared. So this becomes the square root of 4 tangent squared theta, which is 2 tangent theta. And again, this is going to be a very, very important skill for us when we get to something called inverse trig functions. And also a very, very important skill if you go on to take calculus. Do something called integration by trigonometric substitution. This is exactly what you're doing. You're substituting in a trigonometric thing to get rid of your square root. All right, and then the other thing it asks us to do is write sine and cosine in terms of x. I'm going to draw myself a triangle here. This tells me that secant of theta is x over 2. So how would I label my triangle if this is my angle theta? Where's the x go? Where's the 2 go? X is the hypotenuse. 2 is the adjacent. Well, that makes it pretty easy to find cosine of theta. I didn't really need a triangle to find cosine. What's cosine have to be? 2 over x. You just flip it over. And how about sine of theta? What would I have to do to find sine? Find the missing side, use the Pythagorean theorem, but I told you the other day that what happens is you get the original thing. So this missing side, if you use the Pythagorean theorem, is square root of x squared minus 4.
How would you do the Pythagorean theorem? Would you just label that other side as x? Or?
How would I do the Pythagorean theorem? Let me get some more room here. This is my angle theta. That's a right angle. This one was x and this one was 2. I might call this one a. So I would have a squared plus 2 squared is x squared, because x is the hypotenuse, so x is pretending to be c. So a squared is x squared minus 4, and then I would take the square root. A is square root of x squared minus 4. Okay? But, like I told you, it's always going to turn out to be this thing here that I gave you from the beginning. So if you want to save yourself a little work, trust me and just write it down. Okay, so final answer, sine of theta is opposite, which is our square root of x squared minus 4 over hypotenuse, that's x. Questions on that? All right, then you want me to do number 6 also? Might as well, huh? And then I told you I was going to do number 5 anyway, so we'll go back and we'll do number 5. Simplify. Sine of a plus b plus sine of a minus b. What might you do?
Did you plug in like the formula that?
You would plug into the formula that we have. That's exactly right. So we're going to plug in sine of a plus b. So according to that formula, sine of a plus b is sine a cosine b plus sine b cosine a. So that's the first one. And then I do the same thing with the second one. The second one's going to be sine a cosine b minus sine b cosine a. And then what happens? Stuff cancels. What cancels? Those two cancel. And I can add those two together. So final answer looks like 2 sine A cosine B. Questions on that? All right, our last one here, number 5. Assume that sine of u is 4/5 and sine of v is 3/5, and u and v are angles in quadrant 1. Evaluate sine of u plus v. Well, I'm going to take sine of u plus v, and I'm going to use my formula. What's my formula for sine of u plus v? Sine of u cosine v plus sine v cosine u. Well, a couple of these things I know. I know sine of u. Sine of u is, that's 4/5. Do I know cosine v? No? All right, I'll leave that one blank for a minute. Plus, do I know sine of v? Yep, that's 3/5. And do I know cosine u? No.
So it wouldn't be like sine 4/5.
It would just be sine of 4/5 because it says sine of u is 4/5. So it's not sine of 4/5, it's just 4/5. All right, well, I need a number for cosine v. How am I going to find a number for cosine v? Draw a triangle, okay. That's always a good answer in this class. There's a triangle. What do I do with it? I can call this, I'm going to call this right here, this is I'm going to call angle V. And I know that sine of V is 3/5. So how would I label this triangle? Opposite 3, hypotenuse 5. And I go talk to Pythagoras. He would tell me the other side is 4. That's a famous 3, 4, 5 triangle. So what's the cosine of V? 4/5. What's the cosine of U? You do the exact same thing again. You draw yourself a triangle, but you notice if this one is 4/5, the other one's going to be 3/5. So I could draw my triangle. I will. It's always a good idea. And this is my angle U. I know sine of U is 4/5. So again, this has to be a 3, 4, 5 triangle, which tells me cosine would have to be 3/5. So looks like my answer is 16 over 25 plus 9 over 25, which is 25 over 25, which is a fancy way of saying it. Questions on that? How about homework? Anybody started looking at the homework on my lab yet?
Yeah.
Yeah, some of them?
It's
Question?
like number 8 or 7.
Is it on 7.1, 7.1a or 7.1b?
I think B.
You think B. You think it was number
7 or 8.
7 or 8? All right. Uh-oh. It used to work. There it goes.
No.
No?
Maybe it was 7.1.
No?
I think I thought I knew what I was doing, but it was like, no. The answer is just wasn't working. Those ones look confusing, but it really wasn't.
It looked confusing, but it really wasn't?
No, that's the bottom piece, that one. But it's not that one.
No? So we don't see it. All right. So here's what are you going to do? go home and figure out which one you had a problem with and come back on Monday and let us know. Or, of course, there's always this Ask My Instructor button. If you're working at home, what's that Ask My Instructor button going to do? It's going to email me, all right? So those are your options. So figure out which one it was, Felicia, and then come back Monday and let us know. All right? And I'm going to give you a warning. When I passed back the first test, I showed you that people who didn't do the homework in general didn't do very well. And Chapter 6, a lot of that was review. A lot of what we did in Chapter 6 was right triangle trigonometry. My guess is most of you had seen that before. Chapter 7, Chapter 8, a lot of that stuff is going to be new to you. It's going to be very important that you do the homework and earn the extra credit, or I don't think you'll do very well. So if you haven't started doing the homework yet, I highly recommend you start doing it now. Questions on that? All right then, today we move into section 7.2. Section 7.2, we're going to have even more trig identities, as if we haven't had enough of them. All right, back in Chapter 6, we had those two identities, and those were called the co-function identities. So fill in the blank. What's sine of pi over 2 minus theta the same as? Let's draw a triangle. This is my angle theta. I'm just going to call these A, B, and C. What would sine of theta be? Sine of theta would be A over C. How about cosine of theta? B over C. Cosine of theta would be B over C. Where's the angle pi over 2 minus theta? It's the top angle, because if this is 90 degrees, these two angles have to add up to 90 degrees, and 90 degrees is the same as pi over 2 radians. So this angle up here would have to be pi over 2 minus theta. So what's the sine of that angle? What's the sine of pi over 2 minus theta? B over C, which is the same as cosine of regular old theta. And now that we have that one, this one's probably pretty obvious. What's the cosine of pi over 2 minus theta? Sine theta. We also looked at these in terms of graphs, didn't we? And what do we notice about sine and cosine when we look at their graphs? They were really the same, except they were off by a what? A phase shift of a factor of pi over 2 would mean you're multiplying by pi over 2. A phase shift, sliding them right or left. All right, so there are more co-function identities, and they're listed on this sheet here. So it also says if you have sine of x plus pi over 2, that's the same as positive cosine. If you have sine of x minus pi over 2, that's the same as negative cosine. And then they switch. This one's kind of interesting. If you have the cosine of x plus pi over 2, you get a negative sign. And the cosine of x minus pi over 2 is positive sign. And we're going to prove one of those. Which one do you want to prove? You want sine or cosine? You want a plus or a minus? A plus. All right, so we'll do the cosine of x plus pi over 2. Well, what could I do with that? Do I have a formula for cosine of add two angles together? Yes, I do. What's that formula? Let's see, the formula says if I'm adding two things together, it's cosine cosine minus sine sine. So we're going to have cosine x cosine pi over 2 minus sine x sine pi over 2. Cosine of pi over 2, that's a really nice number. What's the cosine of pi over 2?
Zero.
0. You sure? Didn't sound sure. 0, okay, so this one's 0. Cosine of pi over 2 is 0. So what's 0 times cosine x? 0, so this one's 0. Minus, what's the sine of pi over 2? That's also a really nice number.
1.
That one's 1. So there's that identity. Cosine of x plus pi over 2 is minus sine x. So those 4 identities, these 4 new cofunction identities, that's where they all come from. They come from using the sine a plus b or the cosine a plus b formulas. Okay, so I'm not going to prove all 4 of them. There's one of them for you. Now, what I don't see are formulas for the other functions. For example, what if I wanted to know the secant of x minus pi over 2? I don't see a formula on this formula sheet for that. So I'm going to figure one out. How would I figure out a formula for cosine or secant of x minus pi over 2? What do you know about secant? Close. It's 1 over cosine. All right. So this is 1 over cosine of x minus pi over 2. And now I can look on my sheet. What's the cosine of x minus pi over 2? Sine x, because cosine of x minus pi over 2, the minus is on bottom here, the plus is on bottom there. So the minus goes with the plus. So this is 1 over sine x. And 1 over sine x, we could write that as cosecant x. Questions on that? All right, the next formulas that we have are called the double angle identities. So we're going to have a formula for sine of 2 theta. Unfortunately, just as we saw with most of our other things, I can't just take that 2 and bring it out front, I don't think. I don't think those are the same. Well, let's just check to make sure that those are not the same. Somebody give me an angle that they like for theta. Give me your favorite angle for theta.
30.
30 degrees. So theta equals 30 degrees. So if I plug into the left-hand side, I would have sine of 60 degrees. And if I plug in the right-hand side, I would have 2 sine of 30 degrees. Sine of 60 degrees is square root of 3 over 2. 2 times the sine of 30 degrees is a half. So does the square root of 3 over 2 equal 1? No. So unfortunately, things aren't as easy as you would hope they would be. You can't just take that 2 and pull it out front. Here's what we're going to do instead. I'm going to take the sine of 2 theta. And I'm going to write that as the sine of theta plus theta. After all, theta plus theta is 2 theta. And then what can I do with sine of theta plus theta? I can use the formula. So what's that formula for sine of add 2 things together? So the first one goes sine of the first angle, which is theta, cosine of the second angle, which is also theta, plus, and then it would switch, but it's all theta, so it's really all the same. It's sine theta, cosine theta again, isn't it? So that's going to be 2 sine theta, cosine theta. So there's the identity for sine of 2 theta. And like I say, that's called the double angle identity. Why would you call that the double angle identity? Because there's 2 thetas, you doubled your angle. That's why it's called the double angle identity. And then let's do the same thing for cosine of 2 theta. We would write that as cosine theta plus theta. And how's that formula work for cosine? It goes cosine, cosine. So that's going to be cosine theta plus. Unfortunately, it's a minus in the middle, isn't it? Cosine of x plus y. It's cosine, cosine minus sine, sine. So that's going to be minus sine theta, commonly written as cosine squared theta minus sine squared theta. Questions on that? Well, just to make it more fun, or more confusing, depending on how you want to look at it, this one's also sometimes given in alternative forms. You'll sometimes see this written as cosine squared theta minus, what can you tell me about sine squared theta? In terms of the Pythagorean identity, what's sine squared theta? Sine squared is 1 minus cosine squared. So quite often, instead of writing cosine squared minus sine squared, we replace that with 1 minus cosine squared, and we simplify. So we have cosine squared minus a negative cosine squared. That's 2 cosine squared theta minus 1. And then, just for fun, sometimes we'll do this. Cosine of 2 theta is cosine squared theta minus sine squared theta. I could rewrite the cosine squared. What's cosine squared? Using the Pythagorean identity. 1 minus sine squared. So this could also be written as 1 minus sine squared theta minus sine squared theta. So final answer is 1 minus 2 sine squared theta. So you'll notice on this formula sheet, under the double angle identities, typically there's 1 for sine. Sine of 2 theta is 2 sine theta. But when you deal with cosine of 2 theta, it's usually given in 3 different forms. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. So that double angle identity is quite often written 3 ways. Okay, so that's why all 3 of them show up on your formula sheet. Questions on that? Okay, so here's the kind of problem you might see with these. Sine of theta is... Somebody give me a number. Anybody got a number they like? 10. Sine of theta can't be 10. How come sine of theta can't be 10? How big can sine be? What's its biggest possible value? 1. Its biggest possible value is 1. So I want you to give me a number that's a fraction that's smaller than 1. A half. No, let's not pick a half because that's one of our famous angles. 3/4. Sine of theta is 3/4. I want you to tell me, oh, and what angle are we in? Theta is in quadrant number? Theta can't be in quadrant number 3 if sine of theta is 3/4.
So 2.
So it could be in quadrant number 1 or 2. Which one do you like?
1.
Okay, so theta is in quadrant number 1. Okay, I want you to figure out two things for me. I want you to tell me sine of 2 theta. I want you to tell me cosine of 2 theta. And I want to know 2 theta is in quadrant, whichever quadrant it's in. I want you to tell me which quadrant it's in. What are you going to do? Use a double angle identity, okay. So what's the double angle identity for sine of 2 theta? 2 sine theta cosine theta. That's going to be 2 sine theta cosine theta. Do I happen to know sine of theta? Yes, I know sine of theta is 3/4. Do I happen to know cosine of theta? No, but I can figure it out. Very good. How do I figure it out? I draw a triangle. Here's angle theta. So this would have to be 3. That would have to be 4. How long is the other side? It doesn't work as 5 this time. This is not our 3, 4, 5 triangle because 5 would have to be the hypotenuse.
Was it 2?
Is it 2? No, I don't think 2, 3, 4 works. It's the square root of 7. How'd you get square root of 7? I used my calculator. Okay. You would take this side, 4 squared is 16, and then you'd have to subtract this one squared. Because this would be a squared plus b squared equals c squared. So it should be 16 minus 9, which is 7, and then you got to do the square root. Square root of 7. Okay, so here's my answer. Sine of 2 theta is going to be 2 times the sine of theta was 3/4. And what was the cosine of theta? Root 7 over 4. Final answer looks like, I can reduce one of those there. How about 3 root 7 over 8? Okay, how about the cosine of 2 theta? For cosine of 2 theta, I have 3 different formulas I can pick from. Cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. Which one do you like? Which one are you going to pick?
The one with sine. Yeah.
The one with sine. Why do you pick the one with sine?
Because we love sine.
Because that was given to you. That's right. So truth is you can pick any one of those, but you really should, for this problem, use that one because sine of theta was given information. It's always best to use given information. Why?
Because we might
Is it exact?
First off, you're not approximating anything. There's no round off. Secondly, we might have made a mistake in figuring this thing out, in which case if we used the square root, that would definitely be wrong. So we should use 1 minus 2 sine squared theta. That's going to be 1 minus 2 times 9 over 16. That's 1 minus 9/8, which is minus 1/8. Final question. 2 theta is in which quadrant? One, two, three, or 4. You got a 1 in 4 chance of being right? 2. Why do you say quadrant 2?
Because sine of 2 theta is positive, but cosine of 2 theta is negative.
Sine of 2 theta turned out to be a positive number. Cosine of 2 theta turned out to be a negative number. The only way that can happen is quadrant 2. That's correct. Sine is positive in quadrant 2. Cosine is negative in quadrant 2. Questions on that?